you'd quite a bit of homework to go through practicing these types of simultaneous equations, and I'm going to go through the solutions of all of them. And hopefully with this repetition, by the end of it, you'll feel really confident with these types of simultaneous equations. They do come up a fair bit, and like I said, they come up in the topic of coordinate geometry of the circle, which we will be looking at next week. Now, I'm going to start with question 7. So this work is on page 60 and 61 of your text and textbook, and go through the solutions of them. For question 7, we had y equals x squared minus 4x plus 6, and we had y equals 3x minus 4. So this was already rearranged. We already have our linear equation arranged with y on its own. So that makes it really easy to substitute right into our curve. So there's our line and there's our curve. And therefore we have that 3x minus 4, replacing y, is equal to x squared minus 4x plus 6. So next we're going to bring everything to one side. 0 is equal to x squared minus 4x minus 3x plus 6 plus 4. And my quadratic, when I tidy it up, is x squared minus 7x plus 10 equal to 0. And that factorizes using a minus 5 and a minus 2 equal to 0. So my x values are either that x is equal to 5 or x is equal to 2. When x is equal to 5, y is equal to 3 by 5 minus 4. So y is equal to 11. And we have the point 5, 11. When x is equal to 2, y is equal to 3 by 2 minus 4. So y is equal to 2. And we have the point 2, 2. So that line and curve intersect at the points 5, 11 and 2, 2. There's quite a few of them, so I'm going to move briskly through them unless there's anything different to talk about. Question 8, we have a circle, x squared plus y squared minus 4x plus 2 equal to 0. And we have a line, x plus y minus 4 equal to 0. So we identify our line and our curve. There's no power here, so this is my line. And this is my curve. And then we rewrite one in terms of the other. I'm going to, just because x comes first, I'll write x equals a plus 4 when it comes over minus y. 4 minus y. I think this is the first one where we've had a minus in front of the x or the y in our star equation. I'm substituting then into here, replacing x. Might have been easier to replace y, it doesn't really matter. Replacing x, so instead of x squared, I will have 4 minus y squared, plus y squared minus 4 by 4 minus y, plus 2 equal to 0. Let's square out these brackets. 16, double the product, minus 8y, a minus y squared is a plus y squared. Squared out the brackets are gone. Plus y squared minus 4 by minus 4 is minus 16. Minus by minus is plus. Plus 4 plus 2 equal to 0. And then I have y squared plus y squared gives me 2y squared minus 8y plus 4y. Sorry, I keep banging the camera. Minus 8y plus 4y gives me minus 4y, and 16 minus 16 plus 2 gives me plus 2 equal to 0. I can divide across by 2, so I will. X squared minus 2y plus 1 equal to 0, and we have equal roots. That factorizes to give me y minus 1, y minus 1. That multiplies to give you plus 1 and adds to give you a minus 2. So I only have one value here. And y is equal to 1, x is equal to 4 minus 1. So x is equal to 3. And that line is a tangent to the circle because it only touches it at one point, at the point 3, 1. Okay, moving on to question 9. I have another, not a circle, an ellipse, x squared plus 4y squared equals 4, and a line x plus 2y minus 2 equal to 0. So I have a line and I have a curve. I rearrange my line to write it as x equals plus 2 minus 2y, and that will be my star equation. In this case, if I'd written y in terms of x, I would have ended up with a fraction. So I do try and avoid that if I can, but sometimes there's nothing we can do about it. So then I'll substitute into the curve, replacing x with 2 minus 2y. Y stays as it is, and I'll bring the 4 over, changing its sign, because I know that I'm going to end up with a quadratic. 2 by minus 2 is minus 4, and double that, minus 8y, plus, when I'm squaring this, I have to square the coefficient as well as the variable. Plus 4y squared minus 4 equal to 0. And this simplifies to 4 plus 4 is 8, 8y squared, minus 8y, and 4 minus 4, they cancel. So I can divide across by 8, so I will. Y squared minus y is equal to 0. There I can take out a common factor. And remember, y equal to 0 is a valid solution. Y equal to 1. So those are my two solutions there. Right, when y is equal to 0, x is equal to 2 minus 2 by 0. So x is equal to 2. And we have the point 2, 0. When y is equal to 1, x is equal to 2 minus 2 times 1. So x is equal to 0. And we have the point 0, 1. So that line and curve intersect at two different points, at the point 2, 0 and 0, 1. Now, next question then. So hopefully they're starting to become something that's very familiar to you, and the process is hopefully getting easier. They can come up in kind of tricky ways. Look at this one, for example. xy is equal to 4, and 2x minus y plus 2 is equal to 0. So I've no power on either of these, but the one that's a bit strange, I've multiplied x's and y's together, is a curve. It's a type of curve, a curved line. What we end up with is a very strange looking graph actually that comes in two parts, but we'll talk about that more when we do functions and graphs. So we have a curve and a line. I rewrite my line. Now, this time I'm going to write it as y equals something something. Why? Because I don't want to have a fraction if I can help it, because squaring out fractions is a pain. So I move the 2 over there, and I move the 2x over there, and I then have a minus y equals minus 2 minus 2x, and then I change the signs. So y is equal to, I like to have the variable first, 2x plus 2. That's my star equation, which I sub into my curve. So instead of y, I now have 2x plus 2. I'll also bring the constant over here because I know that I'm going to end up with a quadratic. So 2x squared plus 2x minus 4 equal to 0. I can divide across by 2, so I do. X squared plus x minus 4 equal to 0. Now, I don't see factor solutions, so I'm just going to double check my multiplications there. Yeah, that's right. And did I take it down right? I did. So I'm going to use the minus b formula to solve it. So x is minus b plus or minus the square root of b squared minus 4ac all over 2a. And when I put this into my calculator, just the square root part, I get 1 plus 16, so I get the square root of 17. So x is going to be minus 1 plus or minus the square root of 17 over 2. Let's do it to 2 decimal places just to make our answers look a little bit neater. You can leave it in third form, but they didn't specify, so we can do whichever way suits us better. Plus the square root of 17 over 2. And I get 1.56. So x is 1.56, or if I had a minus, delete that and put in a minus, and we get minus 2.56. It's 2.56. So when x is equal to 1.56, y is equal to 2 times 1.56 plus 2, which is 2 by 1.56 plus 2, 5.12. So y is equal to 5.12, and we have the point 1.56, 5.12. Or when x is equal to minus 2.56, y is equal to twice that plus 2. So y is equal to 2 minus 3.12. And we have the point minus 2.56 minus 3.12. So those are my 2 points. Just a reminder again, you don't have to give your answer in point form, but it's good practice because it reminds you of what these mean. So this line and this curve will intersect at 2 different points, and those are the coordinates of the points where they intersect. Right, question 11 was a lot, and if you ran out of time to do it all, that's okay. So y squared plus x times y equals 2, and we have 2x plus y equals 3. Which one is easier to work with? Well, one of them involves squaring out, and one of them involves fractions. So personally, I tend to avoid fractions more than anything else. Y is equal to 3 minus 2x for my star equation, and I sub it in here. So instead of y, I have 3 minus 2x all squared plus x by 3 minus 2x, and bring the 2 over, square out my brackets. 9 minus 6 doubled is minus 12, plus, don't forget to square the 2 in front of the x as well, plus 3x minus 2x squared minus 2 equal to 0. My x squared terms give me 2x squared. My x terms give me minus 9x. And my constants give me 9 minus 2 plus 7 equal to 0. So I can go looking for factors. We could have, just to do it a little bit differently, we could rewrite, that's a plus, we could rewrite minus 9 as a minus 7x minus 2x. And then factorize that by grouping x by 2x minus 7 minus 1x 2x minus 7. So I get 2x minus 7 by x minus 1 equal to 0. And my values for x are x equals 7 over 2 or x equals 1. So those are my x values. Can't completely avoid fractions, and I can use decimals because it's a nice neat fraction. So when x is equal to 7 over 2, which is the same as 3.5, y is equal to 3 minus 2 times 3.5. So y is equal to 3 minus 7, which is minus 4. And we get the point 3.5, or 7 over 2, minus 4. When x is equal to 1, y is equal to 3 minus 2 times 1. So y is also equal to 1, and we get the point 1, 1. Okay, so those are our 2 points of intersection for the line and the curve as given. I can't quite fit it on one screen. Now, let's keep going. Obviously, you can skip any that you knew how to do, that you didn't have any problems with. Question 12, x squared plus y squared plus 2x minus 4y plus 3 equal to 0. And my line x minus y plus 3 equal to 0. So I'll write x in terms of y. It's much of a muchness here. X is equal to y minus 3. That's my star equation. I replace it in here. Y minus 3 squared plus y squared plus 2 by y minus 3 minus 4y plus 3 equal to 0. We'll get a quadratic. Y squared minus 6y plus 9 plus y squared plus 2y minus 6 minus 4y plus 3 equals 0. My y squareds give me 2y squared. My y's minus 6 minus 4 minus 8 plus 9 plus 3 plus 6. And I can divide across by 2, so I will. Y squared minus 4y plus 3 equal to 0. So I've got y minus 3, y minus 1 as my two factors, and the values for y are y equal to 3 or y equal to 1. And then we sub back into the star equation, so when y is 3, x is 3 minus 3, so x is 0, giving us the point 0, 3. When y is 1, x is 1 minus 3, so x is negative 2, giving us the point minus 2, 1. Those are my 2 points of intersection of this line and this curve. So now I don't expect you to necessarily do them that fast, but you can see the steps, the procedure is the same every time. Let's look at question 13. We have s is equal to 2t minus 1 and 3t squared minus 2ts plus s squared equals 9. So another odd looking function here. S is already written in terms of t, so I already have my star equation and I sub it straight in here. I've got 3t squared minus 2t by 2t minus 1 plus 2t minus 1 all squared minus 9 equal to 0. Square out my brackets, 3t squared minus 4t plus 2 minus 4t squared, minus by minus is plus, plus 2t, square this out, plus 4t squared minus 4t plus 1 minus 9 equal to 0. Then my t squareds, minus 1t plus 3t. So basically those guys cancel out and I get 3t squared plus 2 minus 2 minus 2t, and 1 take 9 is minus 8. So I can use my guide number to factorize this and rewrite a minus 2t as minus 6t plus 4t. You see they multiply to give you a minus 24 and they add to give you a minus 2. Then we factorize by grouping 3t, t minus 2 plus 2, t minus 2 plus 4, and we have t minus 2 by 3t plus 4 equal to 0. So t is either equal to 2 or t is equal to minus 4/3. So those are my first solutions, and then I'm going to sub back into my star equation. So when t is equal to 2, s is equal to twice that, take 1, so s is equal to 3, and we have the point, well, which one is x and which one is y, we don't really know here, so I actually wouldn't bother filling in points because this doesn't necessarily represent line and curve in the way that we're used to. So we'll just write down the values in this case. Otherwise, I'm assuming which one is x. It's probably the t, but we can't be sure. And for the second one here, when t is equal to minus 4/3, s is equal to twice that, minus 1. You can just use your calculator for that. It's minus 11/3, I think, but let's find out. 2 bracket minus 4/3, close my bracket, take 1, and I get minus 11/3. Minus 11/3, and just leave it like that because they will be recurring decimals, so we don't want to have a rounding error. If it was something simple like over 2, it's fine to change it to a decimal then. Okay, we're nearly there now. Questions 14 and 15 to go. Question 14, 2s squared equals t squared plus 1, and 2s is equal to t minus 3. You have a choice about what you want to do here. You can either divide across by 2 and have a fraction, or rewrite this as t equals 2s, bringing that over there, plus 3, which is my preference because I like to avoid fractions. So then we fill this in here. That's my star equation, and I have 2s squared is equal to 2s plus 3 all squared plus 1. Square up my brackets and bring everything to one side. So minus 2s squared plus 4s squared plus 12s plus 9 plus 1, and that gives me 2s squared plus 12s plus 10 equal to 0. I can divide across by 2, so I will. S squared plus 6s plus 5 equal to 0, and I have s plus 5, s plus 1 as my two factors. So s is either equal to negative 5 or negative 1. When s is minus 5, s is minus 5, t is 2 by minus 5 plus 3, so t is minus 7. And when s is minus 1, t is 2 by minus 1 plus 3, so t is 1. And there we have our answers. So it looked maybe a little bit different to what we'd seen before. You might have ended up dividing across by the 2 and getting a fraction. Can make your algebra get a bit messy, and it's possible that you might have made a mistake from there. If after going through these questions you have made mistakes and you don't know where the mistake is, you might send me a picture of the work that you've done, and I'll see if I can track down your mistake for you. But hopefully you can figure it out from this. Right, finally, 15. 2t minus 3s equal to 1, and t squared plus ts minus 4s squared equals 2. I'm going to go a little bit more slowly with this one because we cannot avoid fractions. So there's our line and our curve. There's nothing I can do about it. My star equation is going to have a fraction in it. 2t is equal to 3s plus 1, and t is equal to 3s plus 1 divided by 2. So I couldn't avoid the fraction, I had to have one. Now that's my star equation, and we're going to substitute into this curve down here. So everywhere I've got t, I now have 3s plus 1 over 2. I'll take that outside here. 3s plus 1 over 2 minus 4s squared, we'll bring the 2 over as well, equal to 0. Then I'll square out my brackets. I've got 9s squared. So I square the top and I square the bottom. That's how I have to do it. 9s squared, 3 by 1 is 3 and then double it, plus 6s plus 1. And don't forget to square the bottom as well. 2 squared is 4. So you must square the top and the bottom of a fraction. That's from our laws of indices from junior cert. Plus here I get 3s squared plus s all over 2 minus 4s squared minus 2 equal to 0. And now I must deal with those fractions, and what I do is I multiply across by my common denominator. So I multiply here by 4, I multiply here by 4, I multiply this by 4, and I multiply this by 4. That should have been outside the brackets. So everything gets multiplied, every single term gets multiplied by 4. What happens then is that in the terms where I have a fraction, it divides in. It divides in twice there. It can't divide in here because I have nothing under the line to divide in. And this gives me 9s squared plus 6s plus 1 plus 2 bracket 3s squared plus s minus 4 by 4s squared minus 4 by 2 equal to 0. Multiply everything out and bring my like terms together. So 9s squared, 6s, 1, 6s squared, 2s minus 16s squared minus 8 equal to 0. And then I must do my like terms. So 9, 15 minus 1 minus s squared, 6, 8 plus 8s, 1 minus 8 is minus 7, and we'll change the signs. So my quadratic, thankfully not too messy, s squared minus 8s plus 7 equal to 0. So s minus 7 and s minus 1 are my two factors, giving me s equals 7 or s equals 1. A lot of work in this question. So when s is equal to 7, back to my star equation all the way up there, t is equal to 3 by 7 plus 1 over 2, which is 22 over 2, so t is equal to 11. That's my first matching pair. When s is equal to 1, t is equal to 3 by 1 plus 1 over 2, which is 4 over 2, which is 2. And those are my answers. So that was a lot. And the reason we were doing so much was because it was really important to practice all of those. Now, I had a meeting yesterday, so if you did run out of time on Wednesday, my hope would be that you went ahead and used Thursday to work on it a bit further. And if you got stuck, all I'm asking you to do today on Friday is to go through these solutions and identify anything that is causing you problems with these types of equations before we move ahead. Thank you.